saw handle, it has a curve that's in it.
Loads it up to the system and deducts the material automatically. So no matter what happens in the molding department, we've accounted for all the material in a closed loop system. So again, it's just these little things that add up to make sure we have good inventory control along the way. So from these blenders, it comes over to these big dryers. Nylon defense, so you can see that nylon 6 no glass nylon material is nowhere near the good one at 20%, especially 30% glass for the nylon. So the dryers are set up to the perfect dew point to make sure that we don't have splay or potential degradation of material to ensure that our parts are strong. Then we have a manifold back here which brings it overhead. If you look at the pipes overhead and all the glass elbows you'll see there, it brings these over to every single machine. So if I want to change a part over or change a mold, a machine, all I do is I move over the pipe to the new material, I change the source data, and it has to match or it won't pull, and then it pulls it over and the material change can start immediately. So it's all about quality and efficient. Very quick, very efficient now. So you can see some of our molds, we have over 600.
Every design mold. Right.
You guys are more than welcome if you come back by, we'll take a look at that. I want to show you guys the regrind systems that we have. I know this sounds really simple, but one of the ways when I walk a plant, one of the ways that I look and see how people see the ownership and accountability is, during the day these aren't always here, but at the end of the shift they all have to be here, and they better be the right ones. During the day they could be missing, they're using it, but at the end of the shift it tells me who's paying attention. So there's lots of things you can do when you walk a line and say, hey, is everyone wearing their glasses? Is everyone paying attention? Are they looking? Are they concentrating on what they're doing? You can really quickly go through a line. Is there parts out of place? And very, very quickly see who's really on board, what supervisors are owning the area. And it's important to be walking the lines daily to watch for that. Yes. Yeah. So the question was when I said two-shot, what does that specifically mean? So the complication on this one, I've done lots of two-shot molding in the past, but the complication is it's a polyfoam material that is very, very susceptible shot-to-shot variation. And so it creates the undershot, and then the whole mold rotates, which is part of the patentable issue, you know, part of the patentable design, and then it shoots the soft shot over with a secondary injection unit. And it was a real challenge getting that design to work, and all the holding devices we had to put in place to make sure, because the undermold is your shutoff for the overmold. So we talked a little bit about being green, recycling. This is, for the most part, what we recycle. These are the runners used to make the parts. Now, moving forward, every mold we design that has a capability, we don't have runners anymore. We build it with valve gate controllers or hot runners, so there's no waste. So that's even more green. Now we're not even have to touch it and recycle it. So what happens is, used to be people would grab these, they put them into all day long, they put them into a grinder. Now what they do is they take a big tote, they put it up here, they hit a button, it goes through a shredder. And the shredder kind of takes care of the big stuff, grinds it up, then it goes through a metal detector. I can't have metal in my injection units or my tools. It'll be a huge issue, maintenance nightmare. So what it does is it goes through a metal detector, in a split second it'll drop it. Not just metal, but brass, stainless steel, aluminum, anything. If it senses the density, it'll drop it out, and then it will put it into a bin essentially that needs to be essentially sorted through again. And then it goes through a fine grinder, and then from that, it has a pipe that takes it all the way back over to the Motan system, right back into the system, all closed loop. What I really like about the story is it creates dust. When you make regrind, it creates dust. We take the dust from the regrind, we send it out, and we repelletize it, and we bring it back in and use it as regrind. Now, it saves us a little bit of money, but it's more about not landfilling and being green and being responsible to the environment. So that's really important for us. So I love that story. It's only a few bumps here and there. It's not about the money, it's about doing it right. So we want to do things right. We don't want to cut corners. We'll never sacrifice safety, quality, or environmental for any kind of gain. It's always got to be a win-win-win-win. I don't have a good size, though. No. this is sort of a unique challenge. Again, Yamavico and Echo have been working close together. Yamavico told us that there's no way I'm going to transfer the highest volume model to Echo unless we see a significant improvement in quality over the current product. So we invested 9 months and we invested $1 million in 3 machines and new fixtures to be able to improve quality and improve efficiency to keep our costs neutral. So we actually bought these machines a year ago and they're up and running. The SR625, we call it fan cover, but it's essentially the clutch cover. And those are all machined in-house now. We want to be more and more vertically integrated. The more vertically integrated we are, the better we can respond. So if these are coming from Japan or China or Vietnam, I can't respond quickly to demand change. If I'm machining them here, I can quickly turn it around. I can react to the needs of the market very, very quickly. That's what's really important. So our CNC department continues to grow. We continue to build a really strong team over here. Now, if you look here, the portable CMM machine, if you look, I don't know if everybody can see that our quality is equal to or better than any of our suppliers. Every single hour we put a machine, even me, I don't have to be technically sound. I can go take a fan cover, put it on, hit the button, it'll send all the offset data that's required over to the machine operator who will make an adjustment. Using only a quarter of it. When we did that, we were also able to get efficiencies out and make a much better product overall. So that's why we're able to get that in-house.
Who sets your tolerance?
Yamavico Engineering sets most of the tolerances. If it's a part that we produce and make here, we do. So you normally would have, that's another great question, who sets the tolerances? We have such stringent tolerances, tighter than anybody else in the field, tighter than any other of our competitors. We have very tight tolerances. And we're told that by our suppliers, which makes it difficult for capability. But our fuel tanks, our grommet areas, where you've got your fuel lines going in with your grommet, that's got to be important because after time, when it gets a little bit brittle, we don't want fuel leakage, right? So it's extremely tight. Our mounting holes, to make sure we don't have vibration. Vibration's key. We talked about that earlier as well. Our tolerance is extremely tight to the point our vendors are constantly asking for relaxed tolerances, and we don't typically do that unless we run a capability study and really validate it out. So we have very tight tolerances from Yamavico, and then when we do it here, we follow the same sort of, we follow suit, making sure that we make consistent intolerance with very little room. So to give you an example, a mounting hole has 0.1 millimeter tolerance. 0.1 millimeter. That is, I can't see 0.1 millimeter, right? I mean, that'd be like if I had hair, you could, I mean, you know, right there, I can't see it. So 0.1 millimeter, that's nothing. It's crazy. Which one's the parent? We can ask Wayne that, go back in the room, and maybe give you a better answer than I can give you.
Usually when mergers happen, it's to streamline and
traffic, and I want to kind of explain a few things about that room. Come on this way, fellas. So we test every, and I'll answer some questions in a minute that you had. We test every single engine that we produce, even if it's a non-emission, like going to Australia or somewhere else that maybe not have the same guidelines. That doesn't matter. We run every single unit. And every single unit that we run, these are our highest skilled assembly personnel. We badge in their badge numbers so we know who adjusted it. There's accountability. They're running, 2 or 3 on a bench to warm up. But we run everything. We check idle. We check wide open throttle. We make sure it's performing correctly. We check our emissions. We adjust the carburetor for optimal performance, good emissions, solid emissions, and to make sure it's going to work for the end user. Every single unit, and here's the key. When we adjust the unit, if that unit goes over to final assembly and it has not been adjusted, when they go to scan that unit, we can't ship it. It doesn't print a label. It absolutely red flags it. So no unit can go out of here without us running it first. That's a commitment to quality that we have here. Every single unit, even units that don't require the emission standard. So I just want to make sure you guys know when you go to that room, we touch every product. So not only do we pull the recoil, start on the line, make sure everything's good, we rerun it, start it up, and run it at least 3 to 5 minutes of warm-up time. So that's what that room is all about, and that's why it's so important that you guys realize.
I was going to ask how long you run each one. Is there a break-in time or anything?
There is, and the break-in time, depending on the engine, usually it's 3 to 5 minutes in general, depending on the unit. So once we warm up, right, and it's important because we want to make sure that it correlates, what we're running in here correlates to what you see in the field. So the wide open throttle that we see when we first started up, you guys know how it works. It's not always running full speed. It's all over the place. So we let it stabilize, validate that all of the performance measures are there, and then we'll go ahead and release it and adjust the carburetor, release it back. So it's really important that what we see here corresponds to what you see out in the field.
Also, like digital screens in there?
Yeah.
Is that basically sniffing, telling where it needs to be?
So there's two different gauges. We use fuel flow and we use CO both to do our adjustment. I'm not sure which one you're talking about specifically, but we do have CO monitors as well. And one of the questions was, is it safe to be in there? We actually went through about a 2-week deal where we had doctors from around the country come in, do an evaluation, make sure our ventilation is solid. We had everybody wearing monitors both for sound with double and single hearing protection as well, and if we're going in there, we can go in there no problem. But we recommend double hearing protection for them all day long. But we check their hearing, we check the carbon monoxide potential, or carbon, what's the potential for them? Absolutely nothing. Once we got the ventilation correct, we got a clean bill from the doctors, and we want to make sure that people know they're safe. It's important. It's not just about we say we want to care about safety. We invested in them coming in and training all of us to make sure that we had a safe room for these guys. So that's it. And I'm going to turn this over to Ken Sherrick and the engineering team to talk about